Okay, let's get right into it. You've got a device in your hand that can answer pretty much anything, right? But what about the questions it can answer? You know, the ones that still make the smartest people on the planet just shrug? Well, today we're diving headfirst into those beautiful, kind of weird, and totally baffling mysteries that are hiding right under our noses.
Like, why do we hiccup? What is that all about? That sudden, weird little body jerk.
Or why do we yawn? Seriously, I bet just hearing me say the word yawn is making some of you want to do it right now. Why is it so contagious?
And blushing. Why do our faces decide to betray us and broadcast our most embarrassing thoughts to the entire world in bright red?
So here's the thing. These aren't just little glitches. They're actually clues. They're like these little breadcrumbs leading us down a rabbit hole into some of the biggest, most fascinating, unanswered questions about, well, us, about our bodies, our brains, our history. This is where science gets really, really cool.
All right, so first up, let's talk about the weird glitches happening inside your own body. I mean, it's an amazing machine for sure, but sometimes it just does some really strange stuff.
So, what's actually happening when you hiccup? It's basically this weird two-step failure. First, your diaphragm, that big muscle under your lungs, freaks out in spasms, making you suck in air super fast. And then, like a split second later, the top of your windpipe slams shut. That's what makes that hic sound. But why? The best guess we have actually goes way back, to before you were even born. Turns out babies in the womb hiccup all the time. The thinking is that it might be like a training program, practice reps for their breathing muscles so they're ready to go on day one.
Okay, and yawning. It's so weirdly primitive, isn't it? And so contagious. One of the leading theories is pretty cool, actually. It suggests a yawn is basically your brain's built-in cooling system. The idea is that the big gulp of air helps cool the blood heading up to your brain. It's a great theory, but totally not proven yet. But get this, here's something they have found. There's a direct link between how long an animal's yawn is and how big its brain is. So hey, next time you let out one of those huge, epic yawns, don't be shy. You might just be flexing your massive brain power.
And then we have blushing. You know, even the great Charles Darwin was totally stumped by this one. He called it the most peculiar and most human of all expressions. And he was spot on. We're the only animal that does it. We know what it is, sure, it's just blood rushing to your face, but we have absolutely no clue why we evolved to have this bright, unmissable signal for, hey everyone, I'm embarrassed, or I find that person attractive. I mean, it seems like a terrible idea from a survival standpoint, right? Yet, here we are. It's a mystery that's uniquely, fundamentally human.
Okay, so we've talked about the body's weird hardware. Now let's get into the central command, the brain. And trust me, if you thought the body's glitches were strange, the stuff we don't know about our own minds is, well, it's next level.
So, here's a fun thought for you. Might want to sit down for this one. Every single day, thousands of people are put under general anesthesia for surgery. It works. It makes you unconscious. The crazy part? We don't really know how. No, seriously, we know the chemicals do the job, but the exact way they flip the off switch on consciousness, it's still one of the biggest mysteries in medicine. It's like we're all expert light switch flippers, but we have no idea how the electricity works.
And that brings us to the placebo effect, which is just mind-bending. Think about it. You can give someone a sugar pill, zero medicine in it, just sugar, and if you tell them it's a powerful painkiller, their pain can actually go away. It's not them just thinking it's better. Their brain literally starts producing its own pain-relieving chemicals. Your brain can be its own pharmacy, all based on the power of belief. How wild is that?
And speaking of how the brain is wired, here's one of the strangest and most absolute facts in all of medicine. Get ready for this. No one who was born blind has ever been diagnosed with schizophrenia. Not one. Let that sink in. It's one of the few things in science with zero exceptions. But why? We have absolutely no clue. Does sight have something to do with it? Does the brain develop differently without visual input? We just don't know. It's this one solid fact in a sea of questions.
All right, let's zoom out a bit. We've looked at our bodies, we've looked at our brains, now let's look at the ancient software that's running it all. I'm talking about our evolutionary history, this kind of ghost code from our distant past that's still shaping who we are right now.
Take the appendix. For like 100 years, we thought it was just this useless, leftover bit of evolution that did nothing but get infected. We couldn't have been more wrong. The thinking now is that the appendix is actually a safe house for your good gut bacteria. So, when you get really sick, say with food poisoning, and your system gets flushed out, the appendix holds on to a little starter kit of good microbes ready to reboot your whole digestive system. It's not a bug, it's a feature. It's your body's own little biological backup drive.
And that system, it's rebooting.
Well, it's huge. We kind of think of ourselves as, one person. But really, you're a walking, talking ecosystem. You have trillions with a T of microorganisms living in your gut that actually outnumber your own cells. This inner world, your microbiome, affects your digestion, your immune system, maybe even your mood. And we are just barely scratching the surface of understanding it.
Something else we've kind of gotten wrong is laughter. Turns out there are two different kinds. There's the real deal, the genuine, can't breathe, tears in your eyes, belly laugh. That's called Duchenne laughter. But then there's the other kind, the polite little ha-ha you do at work when your boss tells a bad joke. That's non-Duchenne laughter, and it's way more about social signaling than actual humor. And believe it or not, most of our daily laughter is that second kind.
So why did we develop that social laugh? Well, there's this amazing theory from an anthropologist named Robin Dunbar. See, our primate relatives, like chimpanzees, they bond by grooming each other. It works great, but it's a one-on-one activity and it takes forever. So millions of years ago, as our ancestors started forming bigger and bigger groups for safety, they ran into a problem: not enough time in the day to groom everybody. So Dunbar's theory is that laughter evolved as a shortcut, vocal grooming. It gives you that same good-feeling endorphin rush, creates bonds, but you can do it with a whole bunch of people at once. It was a total game changer for building communities.
And how about something literally at your fingertips? Your fingerprints. You probably think they're just coded in your DNA, right? Nope. It's way cooler than that. They form through something called a Turing pattern. Imagine this. When you were developing in the womb, little proteins started building ridges on your fingertips, spreading out like ripples in a pond. But then, other proteins jumped in and said, "Whoa, stop right there," creating the gaps. The final pattern is this beautiful, chaotic result of that start-stop process. And it's so sensitive to tiny little changes in the womb that not even identical twins have the same fingerprints. It's organized chaos.
Okay, so let's bring it all back home, because you don't need to look at ancient history or deep space to find these amazing mysteries. They're literally all around you, every single day.
You know that saying, it's like riding a bike? Meaning it's simple, you never forget it? Well, here's the funny part. Scientists still can't agree on how it actually works. For the longest time, everyone thought it was the gyroscopic effect. The spinning wheels keep it upright. Makes sense, right? Well, back in the 70s, someone built a bike that canceled out that effect completely, and it rode just fine. So, scratch that theory. Then came another theory, the Castor theory. But then they built a bike that broke that rule, and it still worked. The simple act of riding a bike is, to this day, an unsolved puzzle in physics. And it just keeps going. What about Tylenol? Probably in your medicine cabinet right now, one of the most common drugs on Earth. We know it stops pain. We have no idea how. We just know it works. Or how about a cat's purr? We think it means they're happy, right? Well, they also purr when they're terrified or injured. One amazing theory is that they're healing themselves. The super low frequency of a purr is the same frequency used in vibration therapy to help bones and wounds heal faster. Your cat might literally be a tiny, furry regeneration machine.
So, after all this, what's the big takeaway? I think we tend to see science as this big book of answers, right? Like it's all figured out. But it's not even close. Science is really the adventure of asking questions. Every time we find an answer, it just opens up a dozen more, even bigger, even cooler questions, and that's the whole point. The stuff we don't know isn't a sign that science is failing. It's the reason science exists in the first place.
And that sense of wonder is everywhere. It's in the weird little hiccup in your chest. It's in the bike leaning against your wall. All these mysteries are like an invitation to stay curious, to remember that the world is way weirder and more amazing than we think. So I want to turn the question over to you. What's the one beautiful mystery, big or small, that just makes you stop and wonder? Drop it in the comments below. I'd love to see what you come up with.